Physical evidence, individual versus class characteristics, and the product rule. A very important concept for you to understand is the difference between individual characteristics and class characteristics. When you're testing a piece of physical evidence, you're trying to determine what characteristics it has, what properties, what traits that material within that piece of evidence has. Some of those characteristics are individual, meaning that they can be attributed to a specific source with very high probability. This is something that's only going to occur on this one specific item on the planet. So class characteristics, compare that to class characteristics where the properties that you're determining can be associated with a group, but not necessarily a single source. Let's take, for example, the pattern on the bottom of a shoe. So you have at the bottom of your shoe, you have that tread pattern, you have a heel, you have the front of your foot, and they usually have some sort of like grooves and ridges and some sort of a pattern, right? Well, the pattern that's stamped out on the bottom of your shoe is going to be the same for every single shoe of that make and model produced from that factory in that month or year or however long it is they go about keeping that equipment standardized. The rubber in your sole is going to be the same for that type of make and model of shoe as well. The type of rubber, overall shape, color, tread pattern, and similar manufacturer-made characteristics of the bottom of that shoe are all examples of class characteristics. It should go boom over here. Class characteristics. All the shoes of that type have the same thing going on the bottom, at least when they're new from the factory. So if you find a footprint and it points and it looks exactly like this shoe right here, and there's no other alterations, there's no wear, there's no dirt, there's no nicks to the bottom of the shoe, the color hasn't faded, whatever, then you can be reasonably assured that that footprint, that impression, came from this make and model of shoe. Now, if you had the same shoe, I'm gonna have to write over the writing here a little bit. Here's your shoe print, but like the inside of the tread pattern is kind of worn down, so it's like smooth over here and over here, and the treads are have become a little misaligned just from wear and how you walk on your feet on the other side, and the edges are kind of rounded out. They're not as sharp as when they came from the factory, but it otherwise looks like this shoe. Not only can you determine that the class characteristics largely match up, but it also features a great deal of individual characteristics. This wear and tear pattern is specific to that shoe, or at least specific enough that you can bet that other people in the same population don't have the exact same, or in the same community don't have the exact same wear pattern. These types of characteristics can pin down not just the make and model of shoe, but whose shoe it is. You can review these characteristics statistically. So if you aren't, you can, sorry, let me back up a moment here while I'm erasing. I'm trying to do two things at once and it's not working out. Ideally, you'll have a great deal of individual characteristics to work with to identify a piece of evidence as belonging to a specific individual. That's not always going to be the case. Most things lack sufficient individual characteristics to pin an item to a single person. They might have some individual characteristics, but not enough to really be convincing. Basically everything, especially since we all buy stuff at stores these days, and we don't make our own shoes by and large, we don't make our own clothes, we don't manufacture our own cars, these things are mass produced. There's a great abundance of class characteristics that can be obtained from most manufactured items. You can also use class characteristics to identify features of a person. Biological class characteristics are things that apply to everybody, that everybody has, and then has certain variations of. We all have blood. There's a bunch of features of our blood that we all share some variation of. We all have a blood type. For example, you can have type A blood, type B blood, type AB, or type O, right? If you take a bunch of these different features of one item, you can multiply them out to get a probability that the item actually belongs to an individual person. It's kind of the next best thing to individual characteristics. DNA profiling works like this, and they use enough of these features in somebody's genome and ones that occur with sufficient infrequency that it basically boils down to an individual characteristic. So take, for example, somebody's blood factor. They have the genes for type A blood. About 26% of the population has that. So, okay, if that's all you were doing, then you could say there's a 1 in 4 chance that this person could have been the source of that blood. There's another gene, the ESD gene, of which 85% of the population has this gene, and a different gene called PGM2, where only 2% of the population has this gene. These are all types of class characteristics. Everybody has or potentially has these genes in them. You're going to test whether or not the person has that gene, and if they do, what the likelihood in the population they have that gene. The product rule refers to your ability of multiplying these frequencies together to get the probability that the class characteristics combined all point to a specific individual. So remember, with percentages, you'll really be multiplying a fraction. So this will be 0.26, 0.85, and 0.02. One number times another number times another number comes up with the probability that all of these things point to the same. So 0.26 times 0.85 times 0.02. The chance that this does not come from the individual is 0.00442. So remember, we move the decimal point over twice to get the decimal version of the percent, right? So 1, 2, that's 0.442% likelihood that this is not a match. That means that if the person whose blood this is compared to the individual, there's only a 0.442% chance that they didn't come from the same person. By combining class characteristics, by combining different tests on different class characteristics, you can come up with sort of the next best thing to actually having individual characteristics, which are otherwise sorely lacking in evidence.